Okay, so now we're going to go over the answers for today's handout. S2 number 1 released IB questions. So here we've got this log. It's a cylinder with a length of 2.4 meters and a radius of 8.4 centimeters. So the first thing we need to notice is the units here. We've got meters and we've got centimeters. So what I chose to do is I chose to convert this to centimeters. And but we also have to figure out the area of this space right here. So this space right here is the area of the sector. So since this portion here that's cut out is 50 degrees, this degree angle all the way around here is going to be 310. So 310 divided by 360. So first of all, we can get the formula for the area of a sector here in our formula packet. Theta over 360 times pi r squared, where theta is the area angle in degrees. So using that formula, I've got my angle in degrees, 310 times pi r squared. My radius is 8.4. And we multiply all that together, and we get the area of the space is 190.88, blah, blah, blah. And then the volume is the area of the sector times the log length. And there we go. Next question, number 2. Okay, calculate the total surface area of this piece of candy. So the surface area of the sphere is pi r squared, which we also get from our formula packet. So 4 pi r squared gives me the surface area of a sphere. Now this is half of a sphere, so I have to multiply it by half, and then we get this value. And then we also have to add the circle bottom. So we add the circle bottom, and then we get the surface area. And then question B, the total surface area of the candy is known for the gram of chocolate is equal to 244 millimeters squared. So we know that the surface area is 339.29 millimeters squared, and the conversion to grams is 1 gram is 244 millimeters squared. So I need to, this is one of the tricky things. Do I multiply 240 or do I divide by 240? And so what you notice here is the millimeters squared cancels out, and we're left with just grams in the numerator. And that's one way how you can know if I'm supposed to multiply or divide by 240 is looking at the dimensions. And that is called dimensional analysis. And that is something very important in physics. All right. You may want to hit pause before moving on. Okay, so we need to find the distance between points A and point B, and the coordinates here for A is 140, 15, 0 for point A, and this coordinate is 20, 5, 250 for point B. And so we need to figure out the distance. So using the distance formula, so on topic 3 of the formula page, we're going to use this formula. We take the x values and y values and z values and subtract them from each other, square them, add those squares together, and then take the square root. So that's exactly what I did here. I took the x values, subtracted them from each other, the y values, subtracted them from each other, the z values, subtracted them from each other, squared them all, added those squares together, and then simplified. Hit pause if you need more time to look at this. Okay, station M is halfway between points A and B. So I used the midpoint formula in order to figure that out. Once again, the midpoint formula is in the topic 3 page of the formula packet. And then write down the height of the station. So the height of the station is the z-value. Whenever you see the words write down, that means you can't show any work. You just have to write down the answer. Okay, now we've got this lunchbox looking container, and we need to find the area that's painted. So we've got the rounded top, we've got a circle here, and another half circle there. So this 2 half circles is going to give me a circle. Let's just use some different colors here. So I've got the front here, I'm sorry, the front here and the back here is 34 times 42. Okay, and then I've got this side here and the one in the back, so 34 times 90. So that's the back and the front, the yellow sides. We've got the bottom, which is the space down here, which is 42 times 90. And as I said before, we've got this half circle and this half circle, which adds up to a whole circle, which is that right there. And finally, one of the trickier parts is this this part that curves over the top. So this part that curves over the top can be unraveled into a rectangle, and the length of this rectangle is the length around the circle, which is circumference, which is 2 pi r. But notice it's only half of a circle length, so it's going to be 1/2. And the height, the width of this thing here is going to be 90. So that's how I get this top green space here, is the length 90 times pi r, because the 1/2 of this of a circle circumference, and 2 pi r is the formula for circumference of a circle. So that's going to give me this value. So then I add all these values together, and then I get this total surface area. You may want to hit pause to check your work. Next. Okay, so iron in the asteroid 16 Psyche is said to have a value of 8,973 quadrillion, where 1 quadrillion is 10 to the 15th power. Write down the value of iron in this form. Okay, so basically we want this decimal to be between the 8 and the 9. And we know a quadrillion is 10 to the 15 power, so if I'm going to move this decimal over here, I'm moving it 3 spaces, so that's how we get 10 to the 18th power. Okay? I'm going to hit pause if you need more time to think about this. Okay, so James believes the asteroid's approximate sphere with radius 113 kilometers uses information to estimate the volume. So I can use, once again, my topic 3 page for the formula packet, and the volume of a sphere is 4/3 pi r cubed. So using that formula and the 113 kilometers cubed, we simplify it to get this, and then we simplify it to do this. Don't forget 3 significant figures. Okay, and this could be simplified and expressed in either form. Okay, last question. From the formula packet, so I'm going to switch to topic 1. In my formula packet, topic 1 has percentage error. So where is VA minus VE divided by VE times 100%. So VE is the exact value, and VA is the approximate value. So make sure, and then this is absolute value, okay, and times 100%. So I'm going to be using this on the topic 1 page of the formula packet. And so here I've rewritten the formula. You may want to hit pause. So here's the approximate value, which we calculated. Here you should use this value here, not the rounded one. So I'm using the 6043992.8 value, and then minus the exact value divided by the exact value. We simplify it and we get this decimal of 0.00494002. So now convert that to percentage. We move the decimal place 2 spots, and then we get this. So the biggest error I imagine that we're going to see students make is either not converting it to decimal or making a decimal error here. So there you go. There's your answers.